Hello and welcome to the 7-4 Notes. This is a video about parallel lines and proportional parts. So what I want to do first is talk about our first theorem that we've got today, and that is the triangle proportionality theorem. The triangle proportionality theorem. Okay. Pardon my handwriting. And what I want to do is just draw a, standard triangle here. Just any triangle will do. Okay. And I'm going to call this triangle A, B, C. Okay. And then what I want to do is I want to draw in a line in here that is parallel to one of the sides. Okay, so I can come in here and I'm going to call this D and E. Okay, and I'm going to show that this is parallel to this segment. Okay, so we know that DE is parallel to AC. Okay, and so if that's the case, so if a segment inside of your triangle is parallel to another side, okay, then, line DE divides the non-parallel sides proportionally. Okay. Proportionally. And we can go as far as to say that, in this situation, if DE is parallel to AC, then we can set up a proportion and say that BD divided by DA is equal to me saying BE divided by EC. Okay, and that's just what this theorem tells me. Okay, so if these two lines are parallel, then these sides are divided proportionally. Okay, and we can set up a similar type of proportion. Okay. The next one is the triangle mid-segment theorem. Okay, and this is the triangle mid-segment theorem. Okay, and I'm just going to go ahead and draw a standard triangle. Okay, kind of just like what I just had. All right, and so I'm going to call this triangle X, Y, and Z, okay? And I'm going to put another parallel segment in here, just like what we had. And so what I know is that, let's say that, and I'm going to call this a, RQ. All right, segment RQ. Okay, and what I know is that RQ is a mid-segment, okay? And it may not look like it on the picture, but we'll just call it that. And so I'm going to do this. I know that XR is congruent to RY, and I know that YQ is congruent to QZ, okay? So R is a mid-segment if it divides the other sides in half, okay? So what I know, okay, and we can say that if R and Q are midpoints, okay, of X, Y, and YZ, all right, then we can conclude that RQ, Okay, RQ is 1/2 the length of XZ. Okay, of XZ. All right. So, you know, an example of this would be, let's say that RQ is 7. Okay, I know that's half the length. Then XZ would be 14. Okay, so if you see a shape like this, something similar like this, then you can automatically draw that conclusion. Okay, so let's go ahead and take a look at some of these problems. And it says, all right, let's just take a look. It says if JK is equal to 7, okay, so I'm going to come over here and put a 7 in here. And then KH is 21, okay, and JL is 6, then find LI. Okay, figure out what that is. So because these two lines are parallel, I know that it divides these segments proportionally. So what I can do is set up a proportion, and I'm going to take this upper segment, which is 7, and I'm going to divide that by the lower segment here, which is 21. Okay? And I'm going to set that equal to the ratio of the other side, okay, so 6 over x. All right, so 6 over x, and I can set this up and I can solve this. And so if I cross multiply and solve for x, I get 7x is equal to 6 times 21. Okay, if I divide by 7 and by 7, then I end up getting that x is equal to 18. Okay, so Li is equal to 18. All right, that's what we're trying to figure out. Okay, so I'm just using the theorem. All right, number 2, okay, it says if RU is equal to 8, okay, that's 8, and US is 14, okay, if I know that TV is x minus 1, and VS is equal to 17.5, okay, it wants us to find x and the length of TV, all right? So what I'm going to do is I'm going to set up a proportion, and I'm going to take 14 divided by 8. So I'm going to come up here and do 14 over 8 is equal to 17.5, this length, divided by x minus 1. So is equal to 17.5 divided by x minus 1. And what I want to do here, and I've done this on some of the homework keys, but I haven't shown this to you guys yet. If I have this proportion, okay, instead of cross-multiplying with these kind of large numbers, if you can simplify one of these, then that's something that you'd want to do, and this will remain proportional. So if I wanted to divide each of these by 2, okay, if I just divided this by 2 and divide this by 2, then I can set up a new proportion here, and I can say that 7/4, okay, which is the same thing as 14 over 8, is equal to 17.5 over x minus 1, okay? And I can solve that from here, okay? And it might be a little bit easier. So I've got 4 times 17.5 is equal to 7 times the quantity x minus 1. So 4 times 17.5 is 70. Okay, and I'm going to distribute my 7 here, so I get 7x minus 7. Okay, and I'm going to go ahead and add 7 to both sides. So add 7. So then I end up getting that 77 is equal to 7x divided by 7, and so I get that x is equal to 11. Okay, and then I know that TV is just x minus 1, and so I get 11 minus 1, which is just going to give me 10. Okay, so those are our 2 answers that we wanted to find. Okay, let's go ahead and take a look over here. And in numbers 3 and 4, it wants us to determine whether BC is parallel to DE in this case, and we want to justify our answer. So what I'm going to do in number 3 is label it as 15. I'm going to do everything in number 3 in red. Okay, so I've got AD is 15. Okay, let me zoom out a little bit. Okay, I've got AD is 15. Okay, I've got DB is 12. I have AE is 10. And I have that EC is 8. So we just want to verify. I'm going to set up a proportion and see if we get the same thing. And so I would do 15 over 12 So 15 over 12, is that equal to 10 over 8? Okay, and if I cross multiply, I get 12 times 10 is equal to 15 times 8. So I get 120 over here. And then 15 times 8 is also 120. Okay, so if the sides are proportional, then I know that these segments are parallel. Okay, they have to be parallel in order for these sides to be divided proportionally. So I'm going to go ahead and write that. Okay, and I'm just going to say yes. Okay, and my justification is over here on the right. Okay, all right, let's take a look on number 4. All right, BD is equal to 9. So, all right, let me see this. Okay, BD is equal to 9. Hold on a second. Okay, BD is 9. All right. BA, the whole thing is 27. Okay. And then we know that CE is equal to 1/3 of EA. Okay, so here's EA. I'm just going to call this X. And then I'm going to call this 1/3 times X. Okay. And so if the whole length over here is 27, and I subtract off 9, then I'm going to be left with 18. Okay? So I just want to see if we end up getting the same thing here. And all I'm going to do here is set up a proportion and say that 18 over 9 is equal to X divided by 1/3 times X. Okay? Okay, and so what I want to do here is cross multiply and see if we get the same thing. So if I cross multiply here, I'm going to get 9 times X. Okay, and then here I get 18 times 1/3 times X. And so I end up getting that 9X is equal to 18 over 3 is really 6X, and this is false. So no. The answer is no. Cannot do that. Okay, that's kind of a tricky one. All right, let's go ahead and take a look at numbers 5, 6, and 7. Now it says that JH, okay, it says that JH is the midsegment of triangle KLM. So what I know is I know that these segments are congruent and these two segments are congruent. So I know that JH is half the length. So JH, okay, is equal to 1/2 the measure of JM. Okay, so if I take, or I'm sorry, not JM, LM. Okay, and so if I take half of my length here of LM, that's going to be 30. Okay, so I can say that X is equal to 1/2 times 30, and half of 30 is just 15. So X is equal to 15. Okay, all right. Now what I know over here is that I'm trying to figure out the value of X. And so I know that JH, okay, JH is the midsegment, so it does this. All right, those are congruent, these are congruent. Now, what it does is, over here, I know that JH is half the length of this whole segment, okay? Well, the whole segment for LM, okay, is going to be 16. Okay, we got to get double that. So X is equal to 1/2 times 16, and so X is just equal to 8. Okay, so that's pretty simple. All right, let's take a look at number 7. Okay, and what it wants us to do is to find X and Y. Now, what I'm going to do here is I'm going to set up a proportion. Okay. And I want us to look at this in class, okay? So what I know is that, that these two lines are parallel, so these are divided proportionally. So I end up getting this. I end up getting X plus 3 over 3/2 X plus 2 is equal to 2y minus 1 over 3y minus 5, okay? And so this is a little tricky, and I want to see if any of you are able to solve this. Okay, and there might be a special prize for those that can solve this. So if you can solve this, then you will be rewarded. All right, so go ahead and take care of that. Try and do that if you can. If you can't, that's all right. We'll take a look at it in class. But if you solve this, then you will be rewarded and you will get some sort of prize. So good luck. Thank you for watching. Please get started on the homework, and we'll see you later. Thanks. Bye.